Today our topic is branches of chemistry. So let's start our presentation. So chemistry is the study of the substances, especially their structure, properties, transformations, and the energy changes which accompany these transformations. Or it is the branch of science that deals with the identification of the substances of which matter is composed, the investigation of their properties and the ways in which they interact, combine, and change, and the use of these processes to form new substances. Everything is made of chemicals. Many of the changes we observe in the world around us are caused by chemical reactions. Chemistry is very important because it helps us to know the composition, structure, and changes of matter. In our daily life, various chemicals are being used in various forms. Some of those are being used as food. Some other uses of chemistry includes industries and transport, food security and agriculture, science and technology, cooking, cleaning, medicine, environmental issues, polymers, and building materials. Now, chemistry has been divided into five main branches. It includes organic chemistry, inorganic chemistry, analytical chemistry, physical chemistry, and biochemistry. Now, we will explain all these branches one by one. Organic chemistry is the study of the compounds that contain the elements carbon and hydrogen, or it can also be defined as the study of the structure, properties, and preparation of chemical compounds that consist primarily of carbon and hydrogen. For example, petroleum, almost all medicines, and food. Organic chemistry overlaps with many areas, including medicinal chemistry. It is the design, development, and synthesis of medicinal drugs. It overlaps with pharmacology, the study of drug action. Organometallic chemistry. It is the study of chemical compounds containing bonds between carbon and a metal. Polymer chemistry. The study of the chemistry of polymers. Organic chemistry includes physical organic chemistry. It is the study of the interrelationships between structure and reactivity in organic molecules. Stereochemistry. It includes the study of the spatial arrangements of atoms in molecules and their effects on the chemical and physical properties of substances. Inorganic chemistry deals with the study of all elements and their compounds except those of compounds of carbon and hydrogen, which are also called hydrocarbons, and their derivatives. Inorganic chemistry studies things such as crystal structures, minerals, metals, catalysts, and almost elements in the periodic table. It involves all elements, metals, or materials chemistry and their chemical reactions. The branches of inorganic chemistry includes bioinorganic chemistry, which is the study of the interaction of metal ions with living tissues, mainly through their direct effect on enzyme activity. Geochemistry, the study of the chemical composition and changes in rocks, minerals, and atmosphere of the earth or a celestial body. The branches of inorganic chemistry include nuclear chemistry, which is the study of the radioactive substances, and solid state chemistry, which is the study of the synthesis, structure, and the properties of solid materials. Analytical chemistry is the study of separation, identification, and quantification of the chemical components of natural and artificial materials. It is the science of chemical measurement. It provides methods and tools which are needed for gaining insight into our material world. Now, there are four basic questions about a material sample. What? What is the identity of a substance in the sample? Where? Does the sample contain substance X? If yes, then how much of a substance X is in the sample? And what is the arrangement, structure of form? Analytical chemistry is used in the following areas. Forensic chemistry. It is the application of chemical principles, techniques, and methods to the investigation of crime. Environmental chemistry is the study of the chemical and biochemical phenomena that occur in the environment. It relies heavily on analytical chemistry and includes atmospheric, aquatic, and soil chemistry. Bioanalytical chemistry is the examination of biological materials such as blood, urine, hair, saliva, and sweat to detect the presence of specific drugs. Physical chemistry relies on a lot of physics and math to study the changes in energy that happen to matter, the study of the shape of non-living matter, and how that affects matter at the visible scale. Physical chemists typically study the rate of a chemical reaction, the interaction of molecules with radiation, and the calculation of structures and properties. Physical chemistry involves matter and energy. It also involves the heating and freezing of materials, also exothermic and organic reactions, and the nuclear chemistry. Some branches of physical chemistry include photochemistry. It is the study of chemical changes which are caused by the light. Surface chemistry, the study of chemical reactions at surfaces of substances. It includes topics like adsorption, heterogeneous catalysis, formation of colloids, corrosion, electrode processes, and chromatography. Chemical kinetics is the study of the rates of chemical reactions, the factors affecting those rates, and the mechanisms by which the reactions proceed. Quantum chemistry is the mathematical description of the motion and interaction of subatomic particles. It incorporates quantization of energy, wave-particle duality, the uncertainty principle, and their relationship to chemical processes. Spectroscopy is the use of absorption, emission, or scattering of electromagnetic radiation by matter to study the matter or the chemical processes it undergoes. Biochemistry is the study of the chemistry in biological processes of all living organisms. There is an evident overlapping of different branches of chemistry, but they are all observed in the systems of living things. Biochemical research includes cancer and stem cell biology, infectious diseases, and cell membrane and structural biology. Sub-branches of chemistry includes nuclear chemistry, which is the study of radioactive elements and their nuclear properties and nuclear processes which occurs in those elements. Radioactive decay is a process by which an unstable atomic nucleus loses energy by emitting ionizing particles or radiations.